Today we're going to be going back in through airports. We've got one more day after this probably on airports. We'll see how time goes. This is session 2 of 3, and then on our airport systems and stuff we should know, I guess, as engineers and how they work. A little bit of news. So we usually start out classes with our transportation news. I'll do a little piece here on airports. This kind of fits in with what we're doing. And the difference between Reagan and Dulles. This is both Washington, D.C. airports are in the region there. Baltimore would be the other kind of the budget airport near Washington, D.C. Some of you have traveled through there or from that area. You're probably very familiar with these airports and come through that. When Reagan is the old airport, DCA, and it's in downtown Washington, right next to, actually right across Potomac from the mall and from all the central areas and the famous stuff in Washington, whereas Dulles is out in the country. And Dulles was built in, I think it opened in 1962, and it was supposed to be the great new wave, special way of doing airports, right? And had a lot of, at the time, innovative ideas about how to design airports. And there's a cute little video I think we'll see next time on that, in what the thought was, and how to design airports and how to lay them out for that. And you can think back, in the 1950s, air travel took off, pun intended. And so by the 60s, they had realized how more people were going to fly than it used to be. And so airport design, airport layout really became a hot new topic. And so Dulles was kind of on the cutting edge back in the day of how an airport should be designed, or what it was thought of for that. And we'll see more on that later for that. So this is a couple articles I'd come across. And so Dulles was supposed to be the big airport and it was supposed to be taking over. And it turned out the little one, Reagan, was kicking its rear. And that's what this one was kind of saying. Now, Dulles was picking up passengers on the international market, which is what Dulles is, its, I guess, primary most important connections are international flights, whereas Reagan is usually domestic travel through there. After 9/11, which is been 20 years ago now, Reagan was supposed to be getting phased out or calmed down because the airplanes flew so close to the Capitol and the White House and all the important stuff there. Well, it's right across the street basically from the Pentagon. That they were going to lower the number of flights coming in and out of Reagan, and limit that it had to be shorter flights coming in so they wouldn't have as much fuel on board after, obviously, 9/11 when they crashed planes into things. It was the amount of fuel on board that was a problem. So that was some of it. And one of the, I think, takeoff patterns out of Reagan is like right over the mall, kind of almost. And now when you take off out of there, they do a hard turn as they come out, so you don't fly straight over the White House on your exit out of it. Right? So there was a lot of concern from safety-wise or terrorism-wise about Reagan being so close to everything. But it turned out that, by 2017 now, this is 3 years ago, Reagan is still coming back on, and what had happened was it wasn't supposed to be, I don't remember how many miles the flights were supposed to be limited to coming in and out of Reagan, maybe 500 or something like that, because they wouldn't carry as much fuel. And when Congress reauthorizes the FAA each couple of years, I don't know how often they have to reauthorize them and fund them, they'll put stuff in there about, and it's famous, the FAA is, these authorization bills have been famous for having a lot of pork barrel items into it, which is putting in pet projects for your home district. And so, like there's a federal FAA control tower that was built in Elkhart, Indiana on an airport that really doesn't need it. And everybody was doing that. So all the congressmen were throwing in special projects in their home region, because that was a way to, send money back home and hopefully get reelected, I think is what the idea is. In these packages, then they started writing in that, not only Reagan is limited to whatever 500 miles or whatever the limit was, and they can have a flight from Seattle because that's where I live and I want to fly to Dulles. And I don't Sorry, I want to fly to Reagan, and I don't want to fly to Dulles because it's way out of town. And so it started breaking down pretty quickly, you know, a few years after 9/11, that everybody from their home district was allowing special flights to come into Reagan, and they put it in this federal authorization bill, so the FAA can't overrule it. So it's kind of weird, but anyway, that started breaking down this wall, I guess. So you're supposed to fly into Dulles, which is way out here. Dulles is what is it, 30 to 40 miles outside of Washington. I think if you had a direct route, right? But this is famously congested around the Washington area, and it's hard to get to, right? And I know the only once that I think I ever fly into Dulles. Well, when I got there, to Dulles, you know, we were staying in a hotel in downtown. You had to ride a bus into, I think, Tyson's or Falls Church, and there you caught the metro, and then you in there. It was over an hour total time by the time you got out of Dulles and hit the first bus until you could get downtown. I think it was probably seemed like forever. And you had to do a transfer, and then you had to get on the metro, and then, you know, and all that. And it's good, you know. You had to buy 2 tickets. I don't know, it wasn't that expensive, but it was enough for that. Whereas Reagan is over here. Reagan is right here. Here is the Washington or Lincoln Memorial right there. The Washington Monument's right there. So here's the runway, right? You take off, you go straight up. You'd go right over the top of the White House, basically in the Washington Monument. So now they come up. If you're taking off in this direction, you do a hard left as you come out, and it's an awesome view. It is. It is really nice. So if I go to DC anymore, I always fly into Reagan because, unlike everybody else, I want the convenience. I want to be there close, right? The metro right here is the Pentagon, right? So it was across the street. The metro station's right here. You can walk right into the metro station. It's right connected to it, and shoom, right across. There's a bridge here, and you're right into downtown DC. You can be in your hotel in 10 minutes. Coming out of Reagan, right, compared to Dulles. And Dulles is getting the metro connection, but it's still being built, right? They're not even done yet. And it got close. It's up to about here now, and they're working on the last few miles and trying to get it approved so they can use it. So that's been the battle of these two airports. Like the Dulles was supposed to take over, and it was the next big thing, and it was great. And what it's turning out is convenience is winning. And so Reagan is packed, and they probably really, I think they're about out of landing slots right through there. You can't get many more flights into it, and it's a really cramped, tight airport for that. And you can't get very big, super big planes in here, and that's why Dulles has always been the international airport, right? But for, you know, 757, 767s definitely can land here. Probably nothing bigger than that. It is packed, right? I usually fly Delta. They have this really cramped old terminal with, it looks like it's from the 60s and for there. Now they've done some updating, and everything's looking nicer there. The last time I flew, I don't remember which airline I was on, but it was a much nicer terminal coming through there. So that's the difference in that. So keep that in mind, right? Location matters in airports as well as anything else, and they say that in real estate a lot. And convenience is the big deal, and being connected to the metro. This used to be a raging debate how Dulles still didn't have a mass transit connection into Metro DC. So it's getting one, but many years later, and anyway, it'll get there, right? So then it'll be a little bit better to fly into Dulles. I still think, that's a long train ride, right? That's going to be a 15-minute train ride out to Dulles. That's a long way out through there. A couple of we looked at 747s last time. I thought I'd show you. This is a cool airplane that NASA owns and operates. This out in California, in Palmdale. This is Sophia. Sophia, I don't remember. Stands for something, strategic observation, blah, 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 blah. It's a old 747 with a telescope in the back, right? And so here's the inside of what the telescope looks like. Here it is taking off. It's a 747 SP, right? You may think, well, that thing looks weird, right? It is short. It is shortened up. It was a model made in the 70s for extra long range. And so to get extra long range, the rest of the 747 is the same. but they shortened it up to lighten it up. So it weighs less, and it can carry as much fuel, but it weighs less, so it can go much farther. And so a lot of Middle Eastern countries this used to be really popular, this SP model, or as popular as it was, that's the main people who were buying it, because they could fly direct then. For more places. So it had a much longer range. And so it's again, they call it an SP model. SP stands for Special Performance. There weren't a lot of them made. This one was a 1975 model. It was originally a Pan Am airplane. And eventually, the last few ones, you can look on Wikipedia about 747 SP. They it lists where all the last ones are left. And there was one in Yemen that got blown up in a couple years ago during the war through there. So I remember seeing that on there. And so that's where there's still a few out there. I don't know if they fly very often, but there's still a few out there. So this is the NASA one. So they bought this plane. It took them quite a while, but they finally retrofitted it all. And now they fly this telescope around. And the reason is because you can get up to 44 or 45,000 feet. You're up above most of all of the water moisture in the air, in the atmosphere. And obviously it's much less dense up there. So you can do really good observations, right? It's a really good place for a telescope, right? That's why we put telescopes on top of mountains, is to be up above the haze and the moisture and see things more clearly. Well, this is a really tall mountain, right? 45,000 feet. The nice thing is that you can do stuff to it, and you can retrofit it, and you can put new instruments on it while it's on the ground, which is easy to do then, versus a space-based telescope, which could see much better. But you can't, much harder to get to, right? And fix things and to try out new stuff. So this is inside, and so this is the apparatus in here. It turns around, right? So this, as the plane jostles and moves a little bit, this automatically stabilizes in here. This whole thing will turn back and forth to keep on target. And so you target a star, and then it'll keep on that target, right? So this used to be a passenger compartment, obviously, and they took off the inner shell and they built this in here. This is pressurized. So this side out here is not pressurized, and this side inside is, because people are in here. This is the instrument that they're using. This would be the telescope, whatever. It's often infrared is what they're using on this telescope. I think it's a 1 meter, 1.5 meter diameter telescope. So this is the instrument piece here. They can put a different instrument on it and fly and see different things. That's kind of cool. Right, this is it when it's taking off. It's got a garage door on it, and the garage door is closed. And then when they're in flight, they'll open up the garage door, and then the telescope starts observing. Yeah, I thought that was kind of cool. My sister works for NASA. She got me a tour. She actually works on the computer code that runs it. This is inside the plane. All right, so the front, it used to be a passenger aircraft, right? So they left the seats in here. Here's some colleagues of mine, and my sister's back here. Then here's and they just take the wall off because you don't need that to fly. So we'll just, in different sections, if we had to run, it has it's got an entire computer cluster that rides on board with it, so for the real-time observations. And then down, this is the telescope back here, and we're looking toward the back. This is in real time. The scientists can sit here and change, what they're looking at and see what it's doing. And observe while they're in flight, and then obviously they're collecting data that they're going to use when they get back then too. So this is what's inside the aircraft. I think it's kind of cool. This is the hangar in Palmdale where here's the nose. See, I really was there for that. But I think it's kind of, we didn't need these walls actually. Just leave those off, right? And then upstairs behind the cockpit there's this whole huge computer cluster. So it has its onboard computer systems that run everything for that. Anyway, so there's 747 for you, a little one. So I'd never heard of an SP until I saw that one. Back to runways today, we're looking at how to line up runways and how we work on those. We talked last time about what would be important about a runway, what we'd want to keep in mind. And one of them is that we want planes to land in or both landing and taking off, you want them aimed into the wind. And you don't want much crosswind. And so crosswind is dangerous for airplanes, and you can imagine, blow them off target, or you come in, you have to turn a little bit sideways to keep going compared to the ground in a straight line, but you have to vector, if you've got a wind coming in from a 30-degree angle off the center of the runway, you have to vector that force versus what your engines are giving you for that. And so that'll they call that crabbing. you don't want too much of that, right? There's a maximum amount of crosswind that an airplane can handle, and the FAA lists that stuff for us. And so we try to aim our runways into the prevailing wind. And that's one thing to keep in mind, as we'll see that here in a second as we go through that. And then we number runways so the pilots know which runway is which, and everybody else knows which runway is which, the ground controllers and everything as well. And coming back from the days when you had a compass in the plane and you were following some bearing coming from somewhere, right? We number the end of the runway with what its compass direction would be if you were a pilot coming into land. So if we run 27 is a pretty popular runway number. So if we have a runway 27, that would mean if you were looking at your compass, your bearing would be 270, which would be due west. And so if you were on that bearing, you're lined up for that runway. Yeah, because maybe you can't see it yet and you're not sure. Well, you'll know that this runway is aimed due west, whereas runway 9 would be due east. It would be 90 degrees on orientation, right? A north-south runway would be either 18 or 36. So instead of using 0 for due north, they use 36 for 360 degrees. I guess they think 0 is maybe confuse people. If you write a 0 on the end of a runway, it might get lost, whereas 36 is a little more obvious, right? So if we're out at Valparaiso Airport, right, so they have a due north runway and they've got an east-west runway. So the due north one is labeled 36 on one end and is labeled 18 on the other end. And these are found from the satellite image. This is the actual what's painted on the runways through there. So as you're approaching, by the time you read the numbers as a pilot, it might be too late. But as you line up for it, you'll know, okay, that's runway 18. This is runway 36. Even though it's the same physical runway, you would actually, if you had an air traffic controller at Valparaiso, they would actually call them by the different numbers. Right? You're cleared to land on 36. And okay, here you come. And this is the cardinal directions we've got in our 0 is due north, 90 would be due east, 270 is west, 180 south, right? So if you're headed, if you're in the aircraft and you've got a compass, if you're headed due south, your bearing will show 180, right? You'll be showing 180. And so 18 is what we number the end of the runway. Right? So this is the east-west runway. It is exactly due east-west. So what would the number down here be, right? Based on that, right? That's right, 27. So you're headed at, your bearing would be 270 degrees, so we'd write 27 on there. I guess I don't like 3 digits is a little overkill, so they just do 2, right? So we divide by 10, right? And that runway down there, right, that's 9, coming back the other direction. So that's what we have in Valparaiso. For that, you can see here's Atlanta, right? So what would these runways be numbered, right? Let's assume these are due east-west, right? Well, this is 9 left and 9 right because it's going 90 degrees. And if you've got 2 side by side, then they'll call them left and right. And I think you can have up to 3 side by side with the same number. So left, right, and center would be the 3. They're showing only 2 main runways here. So that's 9 left, 9 right. And again, as you land, the air traffic controllers will tell you which runway to line up on. For this end, we have 27 left and 27 right. And it's, again, from the perspective of the pilot. So this is on the left of the pilot. So 27 left matches with 9 right. Kind of weird, but it just depends on which direction you're coming from, just like the bearing does. How about these up here? They look like they're going east-west, just like this one down here, right? They do 8 left and 8 right, right? So they actually just change the number by 1, even though they may technically be lined up exactly east-west. And it would have been a 9, but that's going to be confusing with these over here. So this is 8 left and 8 right, and then 26 left and 26 right. So they just vary it by 1 number. And then finally, how about this guy down here? Also looks like it's due east-west, right? They just use 10, so 10 and 28. Down here. Again, they just changed it by 1 number. And so as you come in, you'll know, all right, if you're on 10, or if you're on 9 left, or if you're on 8 right, you know which runway to line up with. And Atlanta doesn't have north-south runway for some reason. And well, we'll do a talk here in a second about how you pick which direction you're on through that. All right, so here's Atlanta. So that's all we've got. Here's their dedicated map. And this is what you can pick this up. Each airport has an airport diagram. The FAA publishes this. And so you can, before you fly in somewhere, you can download this. And so as a pilot, you'd know what to expect when you get there. Now, commercial pilots fly into these places all the time. They probably don't need these things anymore. But if you were the first time going somewhere, and hopefully a little less busy than Atlanta, you can pick this up and you can see where each of the runways are, and they're all labeled here on the ends, and it shows you where all the taxiways are and where all the ramps are, and so you can get in there. Right, so how do we pick that runway distance? Right, we want to pick it based on the crosswind. And so what they do is they measure the wind direction and speeds over as much time as possible, years, hopefully. And then they create a wind rose, we call it. And the wind rose is kind of the historic data of where the wind normally comes from. And you can see in this video, right, this plane is coming in, and that's that crosswind. So he has to turn the plane off to the side to vector to keep going down the center of the runway. And one doesn't quite succeed going down the center, right? And then you land at a certain angle, and the planes are built to handle it up to a certain angle. And yeah, a lot of smoke flies up because wheels don't like hitting ground aimed in the wrong direction. But then that'll whip you around, right? That thing will whip back around. You'll feel it as a passenger. Well, this is the maximum amount of crosswind. And in airplanes, they measure everything in knots. I guess because they think they're airships. I don't know. But they measure everything in knots, which is what, slightly a knot. One knot is 1.1 miles per hour. I'm not sure. 1 point something miles per hour. So this is whatever. 10 knots is probably more like 15 miles per hour, something like that. All right. So and this is based on aircraft type. All right. And so we talked about 1 through 6 before. This is the A380. These are the 747s and 777s, right? I think the 3 is the 737, would be in the 3 category, if I remember right. Here's the allowable crosswind that you can have, right, for each one of those. And so we orient those into the wind so that planes can land easier and take off easier. And this is what a wind rose looks like. Here's the airport diagram for Valparaiso. Here is the weather data compiled, and they compiled it from 97 up to 2018. All right, so that's a long period they've done. And they're looking at, this is the direction the wind's coming from, and then how far out these bars go is showing you what the speeds are. And so up to, this dark reddish color is 20 plus miles per hour wind speed. This is in miles per hour this time. For that, and what direction that wind is coming from. And you can see that this, southwest quadrant, we actually get more wind coming in out of the southwest quadrant for there, but our runways are either due east, west, or north, south. Well, if there's a day that there's a strong southerly wind, you're going to land and take off on the north-south runway. Strong westerly winds is going to be the east-west one. They typically use the east-west one. If you've paid any attention to aircraft all coming over campus, getting ready to land, they're all using the east-west one, which is their primary runway. But if there's a strong northerly or southerly wind, they're going to use this one, right, for that. So this is, if you had this data in advance, that's how you would lay out. You'd probably want to do more of a diagonal one. You're more likely, it's statistically more likely you're going to be into the wind if you've got one following more this route, right? So that's what the wind rose is trying to show us. So maybe not a great example because they didn't actually match it. Here's ORD. This is O'Hare Airport in Chicago. And you can see this was an older airport, and it used to actually have more of these diagonal runways, and they're getting rid of some of those now and going to more east-west because it can pack more in. All right, so if you're running on these diagonal runways, we've only got 2 of those, right? And you can see it's 22, so it's at 220 degrees is what you're aimed at, or 40 degrees off north if you're going this direction, right? So there's only 2 versus, what, 6 or 5? I think there's 5. They're building a new one, so I'm not sure if this shows the new one yet or not. So there's 5 runways going to east-west. You can handle a lot more traffic, obviously, if you're using all 5 of the east-west ones. Where if you switch over and start running on the diagonals, that precludes you using any of those others, and so you're down to only 2 runways running. So that's not great. And it's mostly larger aircraft that can handle more crosswind, so it doesn't have to be as perfect. But this is the windrows there. And yeah, when they had lighter aircraft, some of these runways may have come from that era. And so they didn't line them up with the primary wind direction, right, for that. And now they say, well, east-west is good enough. Yeah, we can handle some crosswind because we got big planes coming in there. So that's a windrows for O'Hare, right? Here's the seasonal winds in Atlanta, and you can see which direction they're normally coming from through there. They quite often get more of kind of a northwesterly wind coming in, and this is by month and what it is, and what's the how strong that wind is, right? Average wind speed and the probability. So apparently in the summer it's lower wind speeds, and it's less likely. This is the probability. It's less likely it's coming out of that. Whereas February, March, and April, you have a reliable chance it's going to be coming in this direction. How's that for there? So that's they're not too far off, right? It's a different way of looking at that windrows idea coming through that. All right, here's MCO. Anybody know where MCO is? All right, that's Orlando. I'm not sure where they came up with MCO for Orlando, but that's Orlando. And this is their windrows, right? And they actually do have quite a strong northerly one, and all of their runways in Orlando are north-south. They have no east-west runways at all, so they're all north-south in Orlando. Kind of interesting. All right, and here's their runway plan. 85% of the time they're landing and taking off headed south as you come through. And I flew out of there last summer. I don't remember which direction we took off in, if we were going north or south through there. And 15% of the time they'll go this way. So they have these plans in place based on wind direction, and the air traffic controllers and the airlines all understand that. Well, the air traffic controller will tell them, but they have these plans in place like, okay, well, if you're landing this direction, which runway or which taxiways will you use after you land, and how do you get back to your ramps and so forth. And so they'll switch operations at some point. They'll stop landings for a bit and switch operations if the wind is predominantly out of the other direction, right? And so they'll switch back and forth like that. Okay. The runway markings, we've got different on the runway itself. So today is all about the runways, mostly, except for, we'll talk about Dulles and Reagan. The runway markings, there's a bunch of required stuff, right? So just like on the road, we've got centerline stripes, we've got edge line stripes, we've got stop bars. They've got their required markings on the runways itself. And this is all internationally recognized, and so it doesn't matter where in the world you fly, any international airport's going to have the same markings on it, so that's handy, right? And within the U.S., it's controlled by FAA, but there's also an international association, IATA, something like that, that controls that. So it keeps the standards very similar across the world. So if you're an airline pilot and wherever you're landing, you know what to recognize, right? And there's different classes of runways. There's a visual runway. This is well, actually, Valpo may also be a non-precision instrument one, but visual is the lowest, right? The lowest class of a runway. A precision instrument runway is one that has a lot more guide slope and other indicators for airliners coming in, so the pilots know where they're at. So that's a precision instrument runway. And the difference is they have a touchdown zone and they have side stripes on those. All of your major passenger airports, at least in the U.S., are a precision instrument runway now with touchdown and side stripes, right, for there. And that's and how wide the runway. So they've got it, very detailed. How many stripes you put on the end of the runway, I'll show you a picture in a second. How many stripes you put on there indicates how wide it is. So I guess if you remember that as a pilot and you're coming in and you're like, hey, look, it's got 16 stripes. That's a really wide one. All right. I think it's going to be pretty obvious too. You just can't get that many stripes on a smaller one, right? So here's the threshold markings, and the threshold is the end of the runway, right? Here's the end of it. Behind this is the blast zone for that. Here's the threshold. Here's the number marking. so that you know which direction, which runway number this is on, right? And then you've got an aiming point. This is what the pilot should be aiming for. Is you don't want you landing down here on the threshold. You know, there needs to be a little bit of factor of safety. So here's the aiming point, and this is a non-precision VFR, visual flight rules one for that. And if it's a totally visual only runway, you don't even put these threshold marks on the end, and you just have the number on it. And then you still have an aiming point, though, to try to, it's something for the pilots to focus on and know, okay, I'm going for those marks. That's where I'd like to touch down, right, through there. If it's a precision runways, so then they'll show the destination markings in that. They'll have a touchdown zone marking and then still have an aiming point. All right, for that, the aiming point again is kind of visual. The pilot is aiming for that, like they're looking at these marks. They'll land probably somewhere in here, but that's where this is what they can see, right? And they'll probably land a little bit short of that. This is our touchdown zone markings in a precision instrument one, and this is what the precision instruments we'll show you here in a second. This is what they are aiming you for, is this zone. They want you to touch down about in here. The pilot will still be able to see that as they come in. For that. And so here's these threshold markings. Again, this is the aiming point. They'll put some little extra marks after that in case you missed the first one and you wanted to aim for the double stripe one, you know, and so forth. So here's the threshold stripe. The wider the runway, the more you've got on these threshold stripes down here. Here is if you're about to take off, they call this the displaced threshold. You are not allowed. You can run up your jets and take off from here, but you're not allowed to land in this zone. You're not supposed to land before the threshold, right? That's what's called a threshold, right? Do not land in this area before it. This zone back here definitely don't, it's not for takeoff, it's not for landing, it's just a blast pad so that you don't kick up a lot of grass and dirt and stuff. Yeah, so we paved that as part of the runway, and it's not as thick to keep that just so the jets don't kick up a bunch of dust and crap, right? So that's the blast pad for that. If you enter from back here, this is considered a blast pad, and then you can't take off until you're past this point, right? And so that's from here on you could run up the jets. This will act as your blast pad. It also acts as your taxiway getting on there. And if you had no other plane should be behind you when you run up the jets, all right, for blast pad, they should be waiting back over here off the side, which is normally where they wait. For that. It's a little bit more what it looks like as they come in. This is airport lighting. We've got all these lights on the side. You have a visual approach slope indicator. These slope indicator lights, that's what will aim you for that landing area. And as you come in, you'll see that they'll line you up on that. And then often there's a wind sock that's lit out here and telling you which direction the wind's coming. And maybe this is slightly older airports. I think the newer ones don't leave a windsock out there, but I've seen others, mid-size and smaller, still have this out. So as you approach, you can see which way the wind's going, and it's lit. The windsock is lit for you. All right, now they'll tell you on air traffic control which way the wind's coming from, what it is. This is what it looks like as you come in. All right, so here is the threshold, right? This would be your blast pad. You're not allowed to run up your jets until you're past this point. Here's that threshold. Here is your alignment. This is where you want to be aiming for, right? That's your alignment markings. Over here are your glide slope indicators, right? These are the, you can call them BASTI or BAPI or whatever, lights. These, and we'll see here in a second, they light up different to show you if you are on the right approach, right? If you're too low, you'll see a different indication. If you're too high, you'll see a different indication over here. If it's just right, you'll see the just right indication, and then you know you're on the right glide slope to hit right here, right? To hit right there as you come in. This is what they look like. So it's a PAPI, that's what it's called. As you come in, if you've got 4 lights, then if you're too high, you get all white, and then you get 1 red. And then if it's perfect, they're half and half. You get 2 whites, 2 reds. And then you're right on the right guide slope. You're going to land right where they want you to, right? For there, if it's red, then you're too low. If there are more red lights, you're too low. If you only got a 2-light system, you're too high, you're on slope, or you're too low. Right, so that's the bigger airports have these, the smaller ones have this. So that's how you know you're on the right path that you're coming in correctly, right, for that. And again, these are set off to the side of the runway, so as a pilot, you can see these as you approach and as you come in, right. For there, if you want to know what the weather is, this is an automated weather observation system, right? We can call this number. Usually we do this in class, but this year we're not going to. You can call this number and you can hear what the weather is out Valparaiso before you land, right? Why not? Coming actually, I do have my phone here. Let's see if I can call that real quick. If I can dial that fast. Sorry for the pause here, but you know, I guess we got nothing better to do, right? 219-531. And
Celsius. Dew point 06 Celsius. Altimeter 2988. Remarks. Density altitude 0. Porter County Municipal Airport, Valparaiso, Indiana. Automated weather observation 1430 Zulu. Wind 340 at 06. Visibility 2. Mist. Sky condition overcast 300. Temperature 07 Celsius. Dew point 06 Celsius. Altimeter 2988. Remarks.
there you go. So that's what it sounds like. You can call that anytime you want, and you can find out what time. Well, the observation time is in Zulu time, which is Greenwich Mean Time. I had to convert that to whatever. It probably wasn't that long ago. It's obviously automated, and it's a computer voice. It can't say Valparaiso correctly. That's kind of funny. Piece of it, but you could find out what the dew point is, what the temperature is, what the wind direction is anytime you want. So there you go. And if you're a pilot, that's numbers listed for each airport. And so if you got a small, you're flying your Cessna across the country and you're ready to land somewhere, or coming into an airport, you can call this, 20 minutes ahead. And like, oh, okay, here's the weather conditions. And if you're about to take off, you can call that number, find out the weather conditions, and be prepared for that. You can also see it. This is what it looks like on the internet. So you can go from NOAA. They've got an aviation weather center set up there. This is Valparaiso. KVPZ is the Valparaiso. Here's the time, Zulu time. So it's 02-1856 Zulu time. Here, I don't know how to read the rest of this. You they would teach you if you were a pilot. They would it's clear, I think. It's 32 degrees, I don't know, and dew point, so forth. This is all in Celsius. One of these things in here is wind. Here's wind. I'm not. So anyway, I can't convert that myself. But you'd be trained if you were a pilot and you know what this stuff means. There's also an online converter I think I found that'll convert these things. The other thing to look for is for each airport, we've got a notice to airmen. Sorry, it's not politically correct. It's an airmen, not air people. So it's a NODEM is what they call it. And if there's something going on at this airport, they'll put out this notice. And it's kind of an early warning. Like if they're like down here, they got an out of service. I don't know what a LOM is, but it's an out of service runway 27. Yeah, whatever that is not working. So they stick out this notice. And so again, before you arrive or before you leave, you can check this and see. And sometimes like if a taxiway is not in use and has been closed, like right now they're parking jets on taxiways all over the place, they'll put out a notice to airmen, hey, taxiway Alpha 4 is closed. So don't try to use it, right? And that'll be a notice to airmen. Here's the PAPI is out of service, right? We know what that is. That's that slope guidance lights. So theirs broke. And so they're out of service. So, all right. So that's another thing that you can, as a pilot, check out. Right, here's a decoder. Right, even this is understand some of it, right? But you can throw this in here, and it'll tell you, it'll convert that for you. Obstacle tower light. Oh, that's what that was. All right. So there we go. Obstacle tower light in. All right, it's out of service in whichever one it is. So every time something happens at an airfield, they have to put out one of these notice to airmen for that. And then this is our last piece before we finish today. We've got VFR and IFR, and so these are two different. If you've ever done any know much about, I don't know if any of you fly or are interested in pilot licensing and so forth. VFR and IFR are two rules that they fly by. One is visual flight rules, one's instrument flight rules, right? So VFR means you can do everything you need to do just with your own eyes. That's really what it means. And you're manually flying everything, and it's a visual flight rule. Small airports, that's all they can handle is visual flight rules. You can't go through clouds, you can't land in fog, and so forth and so on. Instrument flight rules were built so that you, in theory, can figure out where you're at, know what you're doing, and technically even land without looking up, without being able to see anything except your instrument panel. Which I think would be a little scary, right, through that. And if it's, if you've got the right equipment in your plane, you can do all that, right? And I think, if I remember right, someone told me they teach you to get instrument flight, to get IFR certified, you can't look up. They'll block the windshield from the student pilot, and you've got to land it without looking. So I don't know if that's true, but I thought someone told me that once. And we've got beacons and we've got all sorts of guidance systems. And then even as you're approaching, there are approach indicators. Again, there's some on the side of the runway that would be more of a visual thing, right? But there's also a beacon that will bring you in onto the right runway as you land right through there. And you need that if you're going to do instrument flight rules. So next time we'll pick up from there and carry on with airports one more day.